If you ask software engineers about the modern hiring process, you will hear a consistent complaint. Standing at a whiteboard solving a puzzle bears little resemblance to actual daily work. In a real product environment, developers have compilers, documentation, and existing codebases. In an interview, they are asked to invert a binary tree from memory in 45 minutes using a dry erase marker. Top-tier tech companies are fully aware that a whiteboard challenge is an artificial environment. This is a highly optimized, universally scalable mechanism designed to filter tens of thousands of applicants. Success depends on reverse engineering the company's specific filtering criteria and optimizing the signal you transmit. To understand the criteria, look at the logistical challenge these companies face. They must process massive pipelines of candidates and reach a reliable consensus on who gets an offer across hundreds of different teams. They are guarding against a specific threat. A single poor engineering hire can introduce compounding bugs into a massive distributed codebase, draining resources and slowing down entire divisions. Because of this risk, the interview pipeline is structured to eliminate noise and ruthlessly protect the company from making a bad decision. The system prioritizes the safety and stability of the company's product over the individual experience of the candidate. In tech hiring, a false positive occurs when a company extends an offer to a candidate who ultimately underperforms on the job. A false negative happens when an interviewer rejects a highly qualified, brilliant engineer. This matrix plots candidate quality along the x-axis against the final hiring decision on the y-axis. The upper left quadrant is the false positive. From the company's perspective, this is a catastrophic operational risk to be avoided at all costs. The lower right quadrant is the false negative. While it means missing out on a great hire, it costs the company nothing in actual capital or codebase stability. Therefore, the prime directive of tech hiring is simple: structurally tolerate a high volume of false negatives in order to maintain a zero-tolerance policy on false positives. If you walk away with a rejection, it may not be a definitive verdict on your engineering skills. You simply fell into the statistically acceptable loss designed into their risk profile. If the system accepts false negatives, it raises an obvious question. Why use abstract algorithms to evaluate candidates at all? Companies use algorithms and data structures as a standardized proxy. They provide a universal baseline for computer science knowledge. Asking about trees, graphs, and sorting algorithms strips away the noise. The interviewer doesn't have to account for whether you happen to know the specific syntax of a new language or framework. Instead, they are measuring your general problem-solving horsepower. They want to see how you analyze constraints and develop logic under pressure. This means rote memorization of an algorithm's textbook will fail. Interviewers are grading your ability to construct a fresh solution on the fly, not recall an existing one. The whiteboard algorithm remains the most efficient, scalable measuring stick for determining your capacity to learn the job. Candidates often assume they are graded on an absolute scale, where solving the problem perfectly guarantees a pass, and making a mistake means failure. Major tech companies actually use relative evaluation. This bell curve represents the historical performance metrics for candidates. Your individual performance in an interview provides a single data point. But the interviewer doesn't look at that point in isolation. They evaluate your solution against the historical performance of every past candidate who faced that exact same problem. If you are given an exceptionally difficult question, you don't need a flawless solution to succeed. The grading curve inherently shifts with the difficulty of the prompt. Beyond the questions themselves, companies structure their interview loops to remove individual bias and guarantee an objective assessment. Here, we see the distinct hiring pipelines used by two of the largest tech companies. Under Google's model, your interviewers do not make the final hiring decision. They only collect data and submit written feedback to an independent, blinded hiring committee. Amazon uses a different structure, injecting a specialized interviewer into the loop before the final hiring meeting. This person is known as the bar raiser. They are an external evaluator from a different team, equipped with veto power, tasked solely with ensuring that the new hire moves the overall company baseline upward. To get an offer, you must produce objective, quantifiable data that can survive scrutiny by an independent committee. This demand for objective data extends directly to behavioral interview questions. Technical excellence is simply insufficient without structured communication. This diagram illustrates an interview preparation grid. Long before you enter the room, you map your past resume projects against specific thematic challenges, like past mistakes and conflicts. When asked a question, you deliver your mapped data using the situation, action, result framework. You open with a brief nugget of context, explain the steps taken, and detail the outcome. The action block is the critical component. This is where the committee extracts the exact data they need to evaluate your decision-making process. To provide clear data, you must limit team pronouns. If you say, "we solved it," the committee cannot isolate your individual impact. You must specify what I did. Behavioral interviews are strict data extraction protocols that require highly engineered, formatted responses. Understanding how the company's extraction system works dictates exactly how you should prepare for it. This timeline illustrates a deterministic sequence leading to the interview, building from mastering Big O to implementing core data structures. The critical phase is the mock interview. You must practice verbalizing your thoughts out loud, replicating the real environment's friction. Practicing whiteboard pacing and formatting your responses aligns your output perfectly with the committee's strict requirements. Elite preparation focuses on organizing and formatting your existing knowledge to ensure it survives the extraction process. To navigate the tech interview, you must focus on fresh algorithmic problem solving, combined with precise, structured communication. The process is intimidating by design. Even brilliant engineers will occasionally face rejection, falling victim to the false negative protocol. When you carefully format your technical signal to perfectly match the employer's rigid extraction parameters, it immediately triggers the ultimate reward, the offer. Recognizing the committee's fear of false positives and understanding how relative grading measures your performance alters how you present your solutions. Cracking the coding interview depends on providing the clearest, most undeniable signal in a system explicitly designed to reject noise.